This is Unit 1, Section 2, and today I want to talk to you about a property of matter called density. Now, before we talk about that, let's look at some of the other properties of matter. One is mass. Mass means the amount of matter that's in an object. So just plain the amount of matter. If you were taking physics, we would also call this inertia, but we're not taking physics, so we're going to call this matter. Weight. That's very closely related to matter as long as you stay in the same place in the universe. Weight is the pull of gravity on that matter. Now, since we're going to spend pretty much our whole lives right at the surface of the Earth, the pull of gravity at the surface of the Earth is going to be consistent. And therefore, we can say that the weight of something is proportional to the mass of that object. Now, it would be different if we just decided to take off and go to the moon or something. If we took all our objects with us and went to the moon, they would have the same amount of mass that they have here, because mass just says how much matter is there. They would not, however, have the same pull of gravity on them. The moon only has 1/6 the amount of gravity that the Earth has, and therefore the pull of gravity on them would be different. The force with which they are pulled toward the moon would be much less than the force with which they are pulled toward the Earth. But as long as we stay here, and we'll agree to do that this year, then the weight and the mass are proportional. In fact, most of the time in everyday life, we talk about the weight of something when really we might mean mass. The volume is the amount of space something takes up. So this can be commonly measured in cubic feet, or if you're trying to use the metric system, cubic meters, or maybe cubic centimeters. Or if you're using liquids, we often use liters or milliliters. If you're using the English system, it might be quarts or gallons. But it's just how much space does it take up. It doesn't really tell us how much matter is there, because it kind of depends on what it is. If you have a cubic meter of styrofoam, there's a whole lot less matter there than if you had a cubic meter of rock, right? So that's just a measure of how much space does it occupy. Density, which is what I want to talk about today, is the amount of matter in a given volume. Now, here we have two objects, and they're not exactly the same size, but they're reasonably close. So this is a wood composite, something our deck is made out of, very light. This is a barbell. Given the rusty condition of the inside here, I would say that this is made out of iron. Not very light. So when I lift the two of these separately, it's a huge difference. They're not terribly different in size, but this one's so easy that I could say to myself, oh, I could pile 10 or 20 of these up and not have any trouble lifting them. This one I say, oh, well, maybe 2 or 3, and that's about as much as I would want to lift. So what we've got here is a situation where in the barbell, there's a whole lot more matter crammed into the space that it occupies. So we call that density. We say that this is very dense, and this is not very dense. And we're not talking about the total amount of matter, and we're not talking about the total amount of space, but we're talking about the ratio of one to the other. So when we do a calculation of density, we would say that density is equal to mass divided by the volume. And most commonly in chemistry, you will see mass measured in grams and volume measured either in cubic centimeters or in milliliters. So we have often the unit then is grams per cubic centimeter, because when you do a calculation, the units on the answer are going to be similar to the units that you use to do the problem. And what I mean is this: if mass is measured in grams and volume is measured in cubic centimeters, then the unit on the density is going to be grams per cubic centimeter, like grams divided by cubic centimeters. You do the same thing to the units that you do to the numbers. And it is very important that you always put a unit with your answer. So I am going to erase this. I can find my eraser, here it is, and do a problem. This is water. I colored it a little bit so that you could see it. This is also water, also colored a little bit. And you can see that there's different amounts, which means that there are going to be different volumes and different masses. So this different amount of matter, there's different amounts of space it takes up, but they're going to have the same density because they are the same material. So I don't know the exact amounts here, so I'm going to make something up here. Let's say that I have probably 300 milliliters of water. And I happen to know the density of water, so I'm going to cheat a little bit, and I'm going to say, if I measure the mass of this, it would be 300 grams. So the density then is equal to 300 grams divided by 300 milliliters. So this is going to be 1 gram per milliliter, and that is your final answer. Now in this one, let's change the problem and say we have a smaller amount of water there. Let's say I only have 100 milliliters of water in there. So that means that if I put it on a balance, I would have 100 grams of water. Because I happen to know that the density of water is 1 gram per milliliter. And we'll be using that a lot this year, so you might want to file that away somewhere where you can remember it. The density of water is 1 gram per milliliter. It's not the density of everything, it's not the density of all liquids, it just happens to be the density of water. So it doesn't matter how much water I have, because if I have more, I'll have more grams, I'll also have more milliliters, and it will always divide out to be the same density if it's water. So that means that it's a way we can use to identify an unknown material. So let's say I have 2 chunks of shiny metal, and one of them, so here's some shiny metal that's actually iron, and this is pretty heavy. But you're probably familiar with aluminum enough to know that if I had a chunk of shiny metal that was this size, that was made out of aluminum, it would be much, much lighter. So you can do a calculation of volume and mass, or you can do measurements of volume and mass and do a calculation of density, and sometimes that's one of the factors you can use to identify what kind of metal is this, or what kind of anything is it. But that is the idea of density.